Welcome back to wrap up section 1-6 with me. And this is actually the end of our adventure through chapter 1. So congratulations, you're almost done with your first chapter of Algebra 2. So we're going to wrap up with absolute value equations and inequalities by focusing on the inequality part. So still talking about writing and solving equations and inequalities that are involving these absolute values. Okay, so inequalities involving them. Well, so inequalities, obviously, we're going to ultimately put them on a number line, but we need to consider what this means. So if the absolute value of x is less than 5, okay, well, again, absolute value is talking about the positive and the negative, okay? So distance from 0 is 5 in both directions. And to be less than that, you're going to be talking about being constricted within. So whenever you have a less than with your absolute value, as a value is less than a number, you're going to be talking about being restricted between the negative and the positive. Okay, so that's what this little box tells you right here. Okay, is when you're less than a number, it constricts you between that negative and positive of the number. Okay, so what that means is our process is whenever we're doing less than or equal to, we're going to write as a condensed inequality and then solve it from there. Okay, so let me show you. Condensed inequality, because it's less than, it means this is going to be stuck between -5 and 5. Okay, so less than's always write as condensed, and now just solve. I'm going to subtract 3 from everything. So that's going to be -8 less than 4x is less than 2. Now I'm going to divide by 4. So -4x 0.5. Okay, so these are actually really easy if you think of them as condensed inequalities. That is just squished in between those two values. Okay, so let's try this one. Well, again, less than means it's going to be condensed between those values. So now I'm going to add 4 everywhere and divide by 3. Okay, so we have 4. Now here, -4/3 is about -1.3. So I'm going to put that about right there. And then it's condensed between those two values. Okay. So again, ultimately, that's what we're going for. Okay. Now, so that's less than. What happens when you have a greater than absolute value? Well, this is going to be the exact opposite. So now you're still dealing with the negative and the positive, just like before. But now if you're dealing with greater than, now you're outside. You're not constricted anymore. You're bounding out in both directions. Okay? And so that is what this is trying to symbolize for you. Okay? Is you're working your way out in both directions. And again, this is when you're talking about an absolute value greater than a number. Okay? Now, an easy way to remember, or a nice way to remember this, is when you're writing these, you have to write them as two separate inequalities. Okay? But I want you to recall, so here we're going to have our negative and our positive, just like before, all right? The positive you write as is, When you write the -1, you flip it, okay? That's going to be the easiest way to remember what you're doing. Write it twice, write it completely regular, and then when you write the negative version, remember negative, switch the direction of the inequality. And now, just solve. So here, subtract 6, divide by 2. So here, oh, and that is actually off my chart. So 1, 2, 3, 4, 5, 6, 7, 8. I apologize. That's actually way off the chart. And then this one, greater than or equal to 2. And that one would be right there. So I apologize. This dot right here would be going off to the left, and this one obviously going off to the right. I apologize that the number line doesn't quite fit. All right, and of course, make sure that you always have that idea if you want to isolate the absolute value first. So you would want to subtract that 1 off, and now you do what I just did in the previous one, okay? And here, I'll do it in a different color, where when you write the -1, make sure you flip the sign. +1, write just as it is. So, subtract 10, divide by 5. So x is less than -5. Here, subtract 10, divide by 5. X is greater than 1. And that is how you would graph it. Okay, so again, just make sure these little helpful hints, this reminder here, that's going to really help you as you're writing these. And again, a really quick check is always less than should be constricted, greater than should be bounding out in both directions, okay? So if that's not what you're getting, red flag that you go back and you should fix it, okay? Now, unique cases that we're just going to think about here, okay? Because when it comes to absolute values equaling a number, we've already established that you can't let an absolute value equal a negative number, right? But with inequalities, an interesting situation arises, okay, that I want to discuss with you. So here, the absolute value of x plus 3 is less than -5. Well, the absolute value of x plus 3, no matter what, we know it's going to be some positive number, right? We don't know what it is, but it's going to be positive. Well, would it ever be possible for a positive number to be less than -5? And the answer, obviously, is no, it can't. So this would still be that no solution situation, okay? But think about the right-hand side. So again, this is positive, okay? An absolute value, no matter what, is going to be a positive value. So it doesn't matter what x is, that is going to be positive. Well, isn't any positive number greater than or equal to a -4 or any negative number for that instance? So this is another one of those all real numbers. It actually doesn't matter what x is. Whatever x you put in there, that absolute value is going to be positive, and any positive value is obviously going to be greater than that -4. Okay? So, just some interesting situations that I want to make sure you're aware of and think about as you deal with these situations. And again, that really just comes down to some critical thinking skills of really thinking about what the absolute value is telling you and what it's doing. Okay? Last thing I want to share with you is some word problems. Okay? So, we want to cut a piece of wood 6 inches long, but we will use it if it is between 5.9 inches and 6.1 inches. So basically, we have a target that we're shooting for. We want 6. However, we're willing to accept if it's between 5.9 and 6.1. So basically what we're saying is the length needs to be somewhere in between there. Needs to be greater than or equal to 5.9, less than or equal to 6.1. Okay? So now we're going to talk about tolerance. So what does that mean the tolerance is in this case? How much error are we tolerating? Well, the tolerance is going to be half the difference from the maximum and minimum acceptable values. So here, that means our tolerance is going to be 0.1, okay? Or you could also think of it as 0.6 down to 5.9 and zero point 0.6 up to 6.1 is 0.1. It's 0.1 in either direction. That's how much error we are willing to accept in this case, okay? So we can write it like this, okay? The absolute value of the length minus 6 needs to be less than or equal to 0.1, okay? Now, the way that I'm going to summarize that for you is x minus your goal. Okay, so here our goal was 6, needs to be less than or equal to the tolerance. Okay, that's basically the structure for absolute value word problems. Okay, x minus whatever your goal is should be less than or equal to whatever your tolerance is set at. Okay, so let's take a look at this. In car racing, a car must meet specific dimensions to enter a race. Suppose the desirable height is 52 inches, but the car will be accepted as long as they are between 51 and 53 inches. Write an absolute value inequality to describe the cars allowed. So again, fitting that format, x minus the goal, well, the goal is 52. How much is our tolerance? Well, our tolerance is 1 in either direction. So we could represent it just like that, okay? Because this x minus 52 is the difference, but the difference could be in either direction. It could be positive or negative. So that's what it's taking into account, okay? And simply saying it has to be less than that tolerance, that margin of error, if you will. All right, so that wraps up our last notes for chapter 1. So to wrap up, as always, please make sure to write your summary for me and then come back ready to do your practice work.